So we're on to mesoscale atmospheric circulations. These are the scale of circulations that can happen over a few miles, over a town, or a small part of maybe 2 or 3 towns together. So when we talk about mesoscale, we're dividing that into a lot of gravity winds, and we'll explain those in a second. They include mountain valley breezes, Katabatic winds, Chinook winds, and Santa Ana winds. And we'll also throw in desert winds in there as well. Let's get to it. When we talk about, let me move this up so you can see that a little bit better. When we talk about some of the gravity winds, we'll start off with summer days and with valley breezes. These are breezes that you might find up in the Catskills or up in the Poconos that make the summer so refreshing. There's a physical reason why these mountainous areas are more refreshing. On summer days, the valley walls get the warming effect from the sun at basically a 90-degree angle, and they will convect up parcels that ride on a topographic lift as well. So 2 forms of lifting going together. And that means that you will have a breeze from the valley up to high pressure atmospherically, leaving low pressure on the valley walls. And a valley breeze during the day can really prevent the heat from settling in. So that is a valley breeze during the summertime, and you can work that more into a wind the higher the mountains you have. These are the Grand Tetons out in Wyoming, beautiful in the summer, and you are seeing the convection and the condensation that happens at the higher levels when these valley breezes start in the mid-afternoon. At night, on summer nights, the opposite happens, and this becomes a mountain breeze. In other words, the source is the peak of the mountain, whereas the valley breeze, the source is the valley depth. At night, the mountain peak will cool with the increasing altitude and the radiant emissions overnight. So that air above the mountain peak will become more dense, and it will start to flow downward with the gravitational flow. This is a type of cool breeze that comes in the evening, and that really helps keep the valley floor cool throughout the morning hours. Another type of gravity wind, as opposed to breeze, is a katabatic wind. And we're going to study a couple different levels of katabatic winds and a few different names for what is a gravity wind from a hillside. Katabatic winds are known for being winds that move off of a plateau and down into a valley. Not a lot of height or altitude differential there. There's sometimes not even enough for compressional warming to set in, but sometimes compressional warming does set in, and sometimes it really accelerates the wind downward. But katabatic winds are more known for their streaking through canyons and their very fast speed through tighter gradients and tighter distances in the canyon than anything else. So what I'm showing to you here is a katabatic wind that warmed off of a plateau. Not all will, but they are known for their shrieking winds through the smaller distances. Especially they're known in Europe, in the plateaus that are under the Alps. A type of katabatic wind, but it's not called a katabatic wind, is a Chinook. And the Chinooks are not just in the winter. The katabatic winds are just in the winter. The Chinooks are any time of year. and you've studied the rain shadow. The rain shadow and its compressional warming down in on the other dry side is known as a Chinook wind. So the compressional side of a rain shadow has the warming wind. That is called the Chinook wind. It's on the eastern edge of mountain ranges. It can produce some incredible warmth at incredibly fast paces. Look at there, 49 degrees Fahrenheit in 2 minutes. Unbelievable. So Chinook winds are any time of year and much more dramatic for warming than Katabatic winds. Here is a photograph of a Chinook wall. In other words, this photograph was taken from Denver, looking west, where the condensation is coming at them, has dropped all the snow on the western side of the Rockies, where all the ski areas are. And now this wall is fading away and getting ready to compressionally warm and come into Denver. It's not out of the ordinary for temperatures to rise in Denver up to 40 degrees overnight on account of these Chinook winds. They can be quite violent, and sometimes people put wooden shutters over their windows when they see a Chinook cloud wall. They close up the windows because there's been so many windows that have been shattered by the fierce winds that come down off of Chinooks. Santa Ana winds. These are what you see when these are what you feel when you see the fires on the hillsides in LA. And the fires are coming down the mountains, and they're very, very scary. They are driven by the Santa Ana winds. It is a wind that is usually in the fall of the year. So we're talking about seasonal winds that are coming down off of elevations. These are in the fall. It kind of combines the features of the Katabatic winds and the Chinooks, because these are known as being really shrieking winds through the canyons that are along the Sierra Madre and the Sierra San Bernardino mountains in California. And they shriek through that small distance in the canyons, and they compressively warm dramatically as well. So they are coming from the Mojave Desert through the canyons. They're already hot in the Mojave Deserts. Through the canyons, and they're compressing even more, and they come down as a very, very hot wind in through LA, just bringing the fire with them. So I'll get some really good photographs of the fires, but for right now, you should know that those three type of winds, Katabatic, Chinook, and Santa Ana, all are based on winds coming down from elevations and have some layer of compressional warmth to them. There is also a mesoscale thermal circulation of a dust devil. And what this is an obstruction, kind of like an eddy, an obstruction that causes a circular motion in an unstable atmosphere. In other words, an atmosphere that has really heated dramatically and is now emitting and producing a lot of mixing in the atmosphere. Because remember, unstable atmospheres mix quite frequently. This tends to mix in a circular motion. This is not a tornado. A tornado comes down in a circular motion. Dust devils go up in a circular motion. They can become a real nuisance, not too dramatic. However, they are related to another situation, a haboob, which is a convection with cumulus downdrafts. So that circular motion can lend itself to convection and then downdrafts with a dust storm. This is a dust storm in Iraq that was actually photographed at an army base in Iraq. And it is not unusual to have dust storms of this magnitude in Phoenix, Arizona. So there are your mesoscale circulations there, quite dramatic. And they're going to get even more dramatic when we go to the synoptic scale, which is hemispheric. and then we'll go to the global scale. See you on the other side.